I found that I can dissolve away every stinking thing in these. I mean, all of the organics go away, and the heat spreaders go away. And all that's left is the fiberglass matting and the gold. That's it. I can get rid of everything else, and I can do it with a chemical process. What is the magic ingredient to make wet ashing these things work? Piranha solution. It's a little scary, and you should be scared if you're going to emulate what I'm doing. This is going to be scary. This is going to be dangerous. Well, hello scrappers, Mike here. Welcome back to my channel. So what's going on today? Well, I've got another job for my friend Johnny. You're probably tired of hearing that, but I'm learning a lot processing his stuff because he's really challenging me with some stuff I don't normally deal with or that I don't really like to deal with. And I've got to find ways to deal with it that are acceptable to me. So, case in point, we've got some hard to process BGA chips here. At least I consider them hard to process. They have integral metal heat spreaders in them. NEC, Broadcom, NetLogic, Cisco systems. These are the kind of chips you find a lot inside like routers and switches, Ethernet switches, that kind of stuff. Telecom equipment. And they've got integral heat spreaders on them. But they're just like a gold corner BGA otherwise. But that heat spreader is just a pain in the butt to deal with. You can't process them like ordinary gold corner BGAs. There's problems. And then amongst all these other ones that Johnny sent me are some Sun Microsystems something. Got a heat spreader plate that's gold plated. Most of them have so much heat transfer epoxy on them you can't really see the gold plating, but it's there. And you know, there's a variety of these chips here. Hey, the name Sasquatch 1. Okay. Whatever, Cisco systems. Anyway, processing these has always been a pain in the butt to me. In the past, if I've had to process these, what I've done is incinerated them, crushed them, and then manually pulled the heat spreaders out of the ashes, and then processed the ashes. Because there is good gold in these. There's gold bond wires, there's gold plating, as you can see. There is a good amount of gold in them. And Johnny has sent me a big bag of these things. And I saw them in the box he sent me, and I'm like, oh great, more of these. I just hate processing these things. Maybe I need to find a better way to do it. So I've been putting off processing these for a while and thinking about how best to do it. And because I know there's some good gold here, it's just a matter of getting to it. So the other day I had an idea. I thought, well, I've got some gold corner BGAs of my own to process, and I was thinking about revisiting wet ashing. Because a couple of times I've done wet ashing, it hasn't gone well, it's been a big mess. And I thought, let me see if I can be a little more systematic about it, a little more scientific about it, come up with a better way to do wet ashing that's not so messy and produces better results. So I was doing that on my own stuff. I have some gold corner BGAs. I got to make my own gold every once in a while. So watch for future videos on wet ashing revisited, because it went pretty well. But then I got the idea, what if I tried wet ashing these? What would happen if I put these in a beaker and covered them with concentrated sulfuric acid, cranked the temperature up to the stratosphere, and let them sit for a few hours? What would the result be? Well, I was surprised that it almost worked. I say almost. Didn't work all that well, but it almost worked. A lot of these chips, the heat spreaders are copper for the most part, which makes sense because copper is really conductive and not that expensive. So what I saw was the acid, ate up all of the epoxy in the center of these like it was supposed to, just like it would do with a gold corner BGA. And it separated kinda, but not completely, the fiberglass part here that contains the gold bond wires from the heat spreader, but not completely, like I said. But what I was really intrigued by was how much of the heat spreaders themselves were dissolved by just concentrated sulfuric acid. They would be all, dissolved around the edges. And I'm like, huh, well, that's interesting. The concentrated sulfuric acid was starting to dissolve away the copper heat spreaders. I did a little research and found that, yeah, concentrated sulfuric acid will dissolve copper, but it's generally pretty slow and inefficient. And there was a note there, I think, when I was reading this page, I forget where it was, something about if there's an oxidizer present, it'll go a lot faster. An oxidizer. So I did a little off-camera R&D on these things, and I found that I can dissolve away every stinking thing in these except for the fiberglass matting. I mean, all of the organics go away, and the heat spreaders go away. And all that's left is the fiberglass matting and the gold. That's it. I can get rid of everything else, and I can do it with a chemical process. I don't have to incinerate them, come back and crush them, try to separate out the heat spreaders. I don't have to do any of that. It's fairly hands off. I can start the process happening in the fume hood and walk away for a few hours. Come back, do a little something to it, and then walk away for a few hours. And then come back, and the process is done. So, what is the magic ingredient to make wet ashing these things work? Something I have never ever put on film using Piranha solution. It's a little scary, and you should be scared if you're going to emulate what I'm doing. This is going to be scary. This is going to be dangerous. I mean, hot concentrated sulfuric acid is bad enough already. Hot Piranha solution will dissolve your skin off your bones and then dissolve your bones. So be very, very careful if you decide to emulate what I'm about to do here. I'll show you how this works. All right, for this first on-camera test, these are the chips we're going to use. All right, we're not going to do the bulk of the bag. There are problems. I'll talk a little bit about this as we get into it. I really don't have the sort of equipment I need to do these in bulk using this method. If you've got a ton of these things, I'm sorry to say it, but incineration, crushing, and manual separation is probably your best way to go. Me, I've got too many other projects right now. I just want to get these going, walk away, do some other stuff, come back, and deal with the remains. All right, so that's why we're going to do it this way. Let's get a weight on how much I am going to process. I could probably do a little bit more than this, but we're going to keep it to this for now, just so things don't get too out of control. See if we can get enough gold out of these to actually weigh. You know what? We'll go a full 100 grams. So let me find a couple more, throw on there. And different types. 103, 103 grams. Okay, 103 grams. Let me see if I can fit these all into a 3-liter beaker the way I want to. All right, so I want to put them in epoxy side up. You got two different sides to them. One side's got the epoxy. I want to put them in epoxy side up to start with. I don't want to overlap them too much if I can avoid it. I have all the epoxy to have access to the acid access to the epoxy. That sort of thing. So I'm only going to overlap them a little bit just to try and get everything in here. Everything epoxy side up. I'm going to have to overlap them a little bit to get this many in. Probably won't be too big a deal. We'll see. Unfortunately. All right. And one more can go here. All right. So there we go. That's what we're going to do. 100 grams, all lining the bottom of my beaker epoxy side up. This is where I'm limited. I need something larger in diameter to do larger batches because I don't want to have them overlapping too much. I want the acid to be able to attack everything easily. So especially the initial batch of acid. We're going to do this 2 batches. First thing we're going to do is we're going to cover these with sulfuric acid and put them on high heat and leave that for a few hours. That's it. Sulfuric acid alone. We're not doing the Piranha solution yet. That comes later. After the initial attack of the sulfuric acid alone does a number on the epoxy in there, because that can get quite frothy. This sulfuric acid is a dehydrating agent, and at high concentrations and high temperature, the sulfuric acid will actually attack the epoxy that these things are made of. And epoxy is a plastic. And what's plastic made of? It's made of long chains of carbon, hydrogen, and oxygen. And the sulfuric acid is going to dehydrate that. And the way it's going to do it is it's going to steal the hydrogen and the oxygen out of the epoxy to make water, to dissolve in itself, and leave behind the carbon as a fine powder. So that's how this works. But it can get quite frothy because we're operating at such a high temperature. We're well above the boiling point of water. So this is going to froth a little bit as the water is created. So I want to get through the initial frothiness with just sulfuric acid and just enough to do the job. And then once the frothiness dies down and we've gotten rid of the bulk of the epoxy, then we're going to go to Piranha solution to attack everything else in here. It will get rid of the metals, it will get rid of a lot of the carbon, and we'll be left with basically gold and glass fibers. So let me get this in the fume hood and we'll get started. So you need 2 ingredients to make Piranha solution. You need concentrated sulfuric acid, and you need hydrogen peroxide. Now, most recipes call for 30 or 40% hydrogen peroxide. 12% is what I happen to have. I can get higher concentrations, but I happen to have this. And I can buy both of these at my local hardware stores and big box stores. At least here in the US, your mileage may vary if you are in another country. But anyway, this is highly concentrated virgin sulfuric acid used as a drain opener. Available, well, I guess this is the grocery store even. So this hydrogen peroxide for cleaning and sanitizing. I think I got that at Home Depot. But I've also seen it in Ace, Lowe's, lots of places. So if you want to try the 30 or 40%, you're on your own, because that's going to make really stupid strong Piranha solution. But you can buy hydrogen peroxide that strong from Hairdresser Supply, because they use it for making peroxide blondes, basically. So you can buy it that strong from them, but like I said, you're on your own. So the first initial treatment on the chips, we're just going to use the sulfuric acid. And I have measured out 300 milliliters of sulfuric acid. Now, I've done some testing in the background. Like I said, I was trying to be a little more systematic and scientific with how I approach the wet ashing, so it's not such a mess, it's not so onerous. I found through trial and error that for every 100 grams of chips, 300 milliliters of sulfuric acid works pretty well. So let's get this on the chips in the fume hood and get this initial reaction going. And then once all that frothing and bubbling of dissolving the epoxy goes away, we can put some Piranha solution on there and dissolve everything else that's there. All right, so here we are. Now, my past experience with wet ashing has shown me that you don't want to put too many chips in or too much sulfuric acid, because there's going to be so much bubbling as they, in the crates. They all move around. I was trying to keep them so nicely, not overlapping. But this stuff's really dense, so it just moved everything around. But anyway, I found that you don't want to put in too many chips or too much sulfuric acid, because the initial bubbling will be so bad that it will want to bubble up over the top of your container. And it really doesn't matter how tall your container is if you put too much in here. So we're going to start out small. I'm going to put a lid on it to keep the heat in. We need this to be working as just as hot as my hot plate can get. So I am turning it up to max, and Well, a whole lot of nothing going on until this thing gets good and hot. So I'll give you a look at it as we start warming up. I mean, there's a little bit of bubbling. It might just be air being displaced by the sulfuric acid soaking into things, but there might be a little bit of a reaction there. Um, some of them look like they've changed color a little bit, but really we're not going to see any major reaction until this gets good and hot. Let me get the fume hood going because we're going to make some stinky fumes, and we'll just let this go until it gets good and hot. It's only been a few minutes, but we've got some streamers of stuff coming off the chips in there. Looks kind of reddish at this point, but trust me, once this starts working in earnest, it's going to be completely black, and this is going to be the last times you're going to be able to see what's going on in there, because it's going to be completely opaque once carbon starts being liberated from that epoxy in there. So take a good look. You won't see much more of these chips until we're done. Alright, a few more minutes and it's gone essentially opaque, and we're starting to see some bubbling in there as the acid starts attacking the epoxy. Some of that bubbling is also going to be the acid attacking the copper. It's going to produce some sulfur dioxide, but most of this reaction, at least initially, is going to be the epoxy. That's a much softer target for the acid, and it's going to go after it. And the bubbling should only increase from here. Alright, the liquid has gotten very dark black. The bubbling has picked up a lot. We're also starting to get some fuming in here. This is not quite as bad as doing gold corner BGAs because there's a lot less epoxy to dissolve, but still, the liquid's going to get thicker as carbon is deposited in it. And as this bubbling continues, we may actually see it bubble up the side a little bit. This is where if you put in either too many chips or too much acid, this is where you can get a big bubble over. I mean, I've had a big plug of carbon come right up out of the beaker when I was doing gold quarter BGAs and overloaded it. So it can happen. Alright, I'm going to close this because the fuming is starting in earnest, and the reaction is really kicking off here. Alright, here we go. It's frothing up the side of the beaker a little bit. We've got sulfuric acid fumes coming out. This is where you need a fume hood to do this. You don't want to breathe that. That's nasty. And yeah, it's really, really bubbling now. So this reaction is going to be mainly the epoxy getting attacked, carbon being liberated, but some of it's going to be attacking the copper in there too, the copper heat spreaders. But most of this right here is the epoxy. And this frothing is only going to last a little while. Things are going to settle down. The side of the beaker will stay dirty though, so you won't be able to see that it's settled. And the reaction will slow down a lot once that epoxy is all chewed up by the acid. And then once this reaction is basically done, we're ready for the second act, which is doing the Piranha solution. So stay tuned for that. There, you should be able to see that the worst of the frothing is over. The liquid's settling back down, leaving a scum line on the inside of the beaker. That scum line is hard to remove, by the way. A lot of carbon splattered around the inside of the beaker there. So we are getting near the point where we'll want to do the second addition of acid with Piranha. So I'm going to let this cook for a little while longer, then we'll do that. Alright, it's time to get ready for the second addition. So I'm going to measure out the amount of the liquids we need. I'm going to measure out some more sulfuric acid. And this time, I'm only going to get about 250 milliliters. We may not even need that much, but I'm going to put that much in. And I'm going to measure out some of my 12% hydrogen peroxide. Now, here's the thing. I'm going to put 100 milliliters of hydrogen peroxide in here, roughly. Here's the thing. I'm not going to mix these. Not going to mix them. Piranha solution is not going to exist outside of that beaker in the fume hood. So first thing I'm going to do is I'm going to put this in, and this is going to cool down the contents of the beaker a lot when this goes in because it's cold, so that's good. Then I'm going to put the hydrogen peroxide in a pipette full at a time because I don't want a runaway crazy reaction, which is quite possible because that beaker's hot and we just don't want that to happen. So, all right, let me get ready to put this in and I'll show you how I do it. Okay, I would say the initial reaction, chewing up the epoxy, is essentially over. Now, here's where we're going to make the Piranha solution. Now, I've only done this one time before, and this will be the first time on camera. Anything can go wrong. I am a big believer in beginner's luck. Everything went right the first time. Doesn't mean it's going to go right now. So, we're going to hope for the best. First thing, I'm going to put the cold acid in. 250 milliliters of cold sulfuric acid. I'm going to cover this back up. Now I'm going to start putting in pipettefuls of the hydrogen peroxide, about 3 milliliters at a time. You can't see anything because of all the mist in there, but watch all the mist boiling out. It tells you there's a reaction going on. A lot of that steam, because it's hot in there, but the hydrogen peroxide is also decomposing to form oxygen, and that oxygen is going to help digest the metal in there. And I don't know if you can see it, but we got a lot of bubbling going on now. So I'm going to put about half of this hydrogen peroxide in now. And I'm going to let this cook for a while. And then I'll put in the other half in a little while. And I think we'll be pleasantly surprised with what happens to the metal in here once we get a look at it later. And I don't know if you can see it, but the black stuff in there started to turn brown. Piranha solution's destroying some of the carbon too. Destroys anything organic, including you, because you're organic. So be careful if you try this at home. Oh yeah, reddish brown down there. Let's see, where am I? Maybe one more pipette full and we'll call that half the hydrogen peroxide. Alright, and then we'll wait and we'll put the other half in after this has had a chance to cook for a while and get back up to temperature where we're putting out a lot of sulfuric acid fumes. But I think we got a pretty good reaction going on in there right now. Alright, so we're just going to let it cook for a while. Still waiting on it to get good and hot again after that first addition of hydrogen peroxide. I'm going to give it a good stir here, just like that, and let it continue to reheat and get back up to good high temperature. The liquid's thinned out a lot with the addition of 100 milliliters of hydrogen peroxide to it. But I'm sure there's some good work going on in there. We'll just let it continue to reheat. Alrighty, so this has had a chance to get back up to temperature. It's almost up to 200 C again. Let's see here. Yeah, 191. So it's quite hot. That's one reason I like this method. I can just leave it sit and do its thing for the most part. I have to start it up, come back, hour hour and a half later, put the second dose on and the first dose of hydrogen peroxide. Then just let it sit. I've been doing other stuff. Come back up to temperature really nice. Now we're going to put the rest of the hydrogen peroxide on. And again, we're doing this a pipette at a time. Just, frankly, Piranha solution scares me. I don't want to have a lot of it mixed up at any point. I don't want to be dumping a lot of it into a hot beaker with who knows what kind of reaction might happen. So I'm doing it this way. Call me a scaredy cat if you like. I don't care. Still got all my fingers in both my eyes. So a little bit of caution when you're working with these chemicals can go a long way. We got a lot of boiling down there. A lot of that is just boiling as I put this stuff in, but I mean, we are really consuming that carbon. That carbon is going away. And that's going to make the next step after this a lot easier. Because sorting through tons of black carbon to get it to gold, not easy to do. Yeah, let me see if I can clean off the side of the beaker there. Give you a look at what's going on. Yeah, that's definitely looking more brown than black right now. So that's a beautiful thing. Look at that steam coming out of there. It's hot. It's melting the end of my pipette. Alright, so I got a couple more squirts of this to get in. And then we're just going to, again, let this sit and cook for maybe another hour, hour and a half. I got some other stuff I'm working on. I'll let it go. And then we'll call it done. I'll turn the heat off and we'll let it cool down. Then we'll see what we've got. I am not going to mess with this while it's hot. This is going to have to cool down to pretty much ambient before I do anything else with it, because it's just too dangerous. Oh yeah. Alright. So we're going to let that just sit and do its thing. And when I'm ready to shut it down, I'll show it to you. Alright, let's see what's going on in here. We've been... Ooh, that's hot. Hot, hot, hot. Been cooking for a while. Probe around in here and see if I feel any metal. Ooh, it's kind of hard to tell. There's a lot of fiberglass in here. The Piranha solution won't dissolve the glass fibers, but it should do a number on the polymer part of the fiberglass. I don't really feel any metal. Of course, it's hard to tell. The liquid's, of course, opaque. But I think if there's any metal left, it's got to be just minor. I don't really feel the big chunks, the big clunky heat spreaders anymore. I'm going to turn this off, and we're going to let it cool down basically to room temperature before we do anything else with it. It's just too dangerous hot to mess with. So it's going to be a few hours. Then we'll be back and see what we got in there. But again, that's one of the advantages of this method is I don't have to babysit it. I can go away for a few hours, do something else, then come back to it when it's ready for the next step. So I'll see you then when it's ready. All right, this stuff's had a chance to cool down to ambient temperature. It's going to say room temperature, but I don't know, that doesn't really fly when you're outside, does it? But anyway, oh, doesn't that just look lovely in there? Isn't that nice? Yeah, what a mess. What a mess. So, first thing I'm going to do with this is I'm going to dilute that liquid because it's very acidic. So, we're going to put some distilled water in. Now, why am I using distilled water for this? I could probably get by with just tap water. But here's the thing, the Piranha solution will have dissolved all the metals in here, including the copper and including any silver that might have been in those chips. So that's in the liquid here. If I put tap water in here with chlorine in it, the silver is going to condense out as silver chloride, which I don't necessarily want. This is the liquid over here that I did my initial small-scale test on off camera. And it's had a chance to sit and settle. There's a layer of black gunge on the bottom, but the liquid's blue. It's blue because of the copper it's dissolved. I'll bet there's silver in there too. So we might want to try down the road, especially after I process some more of these things and have some more of this waste liquid, we might want to try recovering some of the copper and silver from it. Possibly. I mean, it's a further avenue for exploration and a possible extra, bit of income. So let me pour this stuff off. I'm going to give it a couple of rinses, and we'll see what's left in the bottom of the beaker after having a couple of rinses to get a lot of this black stuff out of the... Oh, didn't it get warm when I put water on it? Yeah, it was still mostly sulfuric acid in there. Oh, yeah. That's actually burning my fingers. Yeah, that got hot. But what should be left in here is just the fiberglass fibers from those chips and the gold. That should be all that's left in here. There's some fiberglass right there. The metals are all gone except for the gold. And I don't see any yet. Give it a little bit more rinse here. Still a lot of carbon in there. Probably could have benefited from some more Piranha solution to eat up some more of this carbon. But I think we'll be able to rinse the bulk of it out. Oh yeah, oh yeah, oh yeah. Let me give you a look in there with my phone. I see gold wires all over the place in that fiberglass matting in there. There's gold wires everywhere. Excellent, excellent. I'll give you a close-up look at that. Can you see the gold? Yeah, there's gold all through these things. Those are the gold bond wires. See the gold? See the gold? Focus you. Yeah, there's gold everywhere in there. Nice. There's nothing left but this fiberglass and the chip dyes. The chip dyes are there too. They look like metal, but they're not. They're silicone. And the gold. That's all that's here. A little bit of carbon. That's all that's left. Everything else is gone. Isn't that cool? I'm going to give this another rinse or two, and then we'll be ready to try and recover the gold from it. All right, and here it is after a couple more rinses. That's pretty clean. It's not perfectly clean, but I think it's clean enough for our purposes. I think this stuff is ready to go to Aqua Regia. Now, it's very possible I poured off a little bit of gold with the rinse water. So what I'm going to do is I'm going to very carefully decant this off into my storage container over here. And then any solids that are left at the bottom of this, I'm going to return to that just out of an abundance of caution. And then we'll take this in the fume hood, and we'll get some Aqua Regia on it and get that gold dissolving. So I'll take care of this, and then I'll meet you in the fume hood. All right, so just as I feared, there were a few stray gold bond wires in the bottom of that beaker of rinse water. So they're now back in here where they belong with the rest of the stuff. Yeah, that's a dirty beaker. It's going to be dirty after Aqua Regia too. Aqua Regia's not going to touch it. I have found though that Windex takes this stuff off, cuts right through it. So that's a great thing. I can get my beakers clean again. So let's make some Aqua Regia. Speaking of, put some muriatic acid in. Let me start the fume hood first, so I don't get a face full of fumes from this stuff. Not going to put in a whole lot. In fact, that might be too much, but we'll go with it. All right, and then we're going to put some nitric acid in it. And I've got to the point where I'm using the nitric acid from my new source, and I'm just refilling these smaller bottles because they're big 2.5-liter bottles, glass bottles, and I don't want to have to carry those around. But I'll put a link in the upper right where I get my nitric acid these days. So I'm going to put about 6 milliliters in, and that's a little light. So there we go. We'll call that 6 milliliters right there. Give it a good stir. Cover it up and turn the heat on. Not too high, just warm it up a little bit. That gold will go into solution. Even with cold Aqua Regia, it just takes a while. But with a little heat, it goes a lot faster. So we'll get that in solution, and then we'll denox it, we'll filter it, and we'll drop the gold, and we'll see how much gold we got out of that 100 grams of chips. Well, this had a few minutes to warm up. We're starting to get some bubbling in there, some pretty good bubbling. Starting to get some fumes. So I would say the gold is going into solution. Excellent. Excellent indeed. All right, so everything's just going exactly to plan, so we're just going to let this cook for a while till it looks like the reaction's done. All right, now we've got a heck of a reaction going on in there. I'm going to turn the heat down a little bit. Need to be boiling it. I don't think it's quite that hot, but yeah, we got quite a reaction going. Once this calms down a little bit, we'll do a stannous chloride test on it, make sure we got gold in solution, and then we can move on to denoxing and filtering it. All right, looks like the reaction has run its course over here. Let's do a stannous chloride test on this stuff and see if we got gold in solution. I'll bet we do. A little bit more. Put some fresh stannous chloride on it I just made with my on-demand stannous chloride method. I have a video on this. I'll put a link in the upper right. You can check it out. Boom! Yeah, we got some gold in solution. Nice. Very nice. All right. So we're going to denox this stuff. I've got my usual saturated solution of sulfamic acid here. Sulfamic acid is used often as a tile cleaner. Oh yeah, there's some excess nitric there. There'll be a link in the video description to where you can get it. In fact, there'll be links in the video description to everything I'm using here. So this is going to denox this stuff and help dilute it and cool it down a little bit. But we're going to speed up the cooling a little bit more. So add some crushed ice to it to get this cooled down enough that I can filter it this afternoon before it gets too late. So, okay, I'm going to take that off of the hot plate just so it will cool. And then once that ice melts, we'll filter it. All right, we're just about ready to filter this stuff, but I thought I'd give you a look at what's going on in here. Look at the fibers. That's from the fiberglass. The Piranha solution has totally destroyed the fiberglass. The polymer that held all these glass fibers together has been dissolved away. It can't touch the glass, but everything else it can do a number on. So that's kind of cool. All right, let's get this stuff filtered. All right, here we go. Get the pump running. And once I get all this stuff through, dump the remains down into the filter and rinse the pregnant solution out of it. I'll give you a close-up look at it. See what we got here. Kind of cool. Well, it's coming through nice and clear, but it is coming through looking kind of like lime green Kool-Aid. So we didn't get all of the copper out of it, but and there's probably some nickel there too. I wouldn't be surprised. But certainly we got the bulk of the base metals out of it before we went to Aqua Regia. Okay, just got to continue filtering. Alrighty, everything is in the Buckner funnel here. I'm just at the point of rinsing the pregnant solution out of everything, letting it get pulled through by the vacuum pump. Coming through nice and clean and green. But look at that. There's absolutely nothing left but dyes and fiberglass fiber. Looks like maybe some silicone caulking over there, the orange stuff, and some carbon. That's it. Everything else got chewed up by the Piranha solution. Nice. Wow, I got one dirty beaker here I need to clean up. Let me rinse a little bit more distilled water through here. Now, I'm not expecting a huge amount of gold in this liquid because we only did 100 grams of material, and most of that weight was going to be the heat spreaders. So, is this really a practical method, some of you are probably thinking to yourselves. On this small scale, maybe not. If you've got a lot of these kind of chips, incineration, crushing, and sorting out the heat spreaders is probably your best bet. But I have given some thought to how I could scale this up. See, this is my biggest beaker now. I do have some 5-liter beakers on order because I have some bigger jobs I'm going to have to do in the future, but even they are going to be too small to do this on any kind of scale. So I'm thinking about some sort of big, not too low but not too high stainless steel pot. Because from my research, Piranha solution doesn't attack stainless steel. That I could put, no more than a couple layers of these chips in the bottom of it, but I could probably get close to 1 kilo or more in that way in a big pot. And then cover them with acid. Do this, maybe even set up like an IV drip of hydrogen peroxide in there to do the Piranha solution. So that's a possibility. I don't think this would work with my hot plates in the fume hood. I'd probably have to get like a turkey fryer burner or something, but if I get a whole bunch more of these from Johnny, which just might happen, I could scale up that way, or I could go back to incinerating them, one or the other. So anyway, I'm going to let the pump continue to pull liquid off of that stuff up in there, and then once it's done, we'll take this into the fume hood and we'll drop the gold out of it. Meanwhile, I got to clean up that beaker. All right, I have transferred the liquid into a clean beaker. Let's see if we can get the gold to drop here. Got some Stump Out by Bonide, which contains sodium metabisulfite. This should cause the gold to drop. Let me get the fume hood going because we're making some nasty fumes over here. And this is a pretty dilute solution. Like I said, I didn't do too much material, so it might take a bit for the reaction to start. Looks like the colors changed a little bit. More Stump Out's going lumpy on me. That should be more than enough. It just might take a little while. Oh, the liquid I think is definitely getting darker. It may not show it on the video. I'm going to put another spoonful in just to be on the safe side. We're getting some white frothing, so that's a good sign. We'll just let it sit here and see what happens over the next few minutes. Yeah, as soon as I turn off the camera, it starts darkening up. Now, doesn't look all that dark on the viewfinder of the camera, but it's definitely darkening up to the eye. So we will just let it sit here and do its thing. then we'll see. Oh yeah, definitely getting a good gold drop there. We will see just what comes out. I'll probably let it sit overnight and see how much gold we got on the bottom of the beaker in the morning. Alright, it's the next morning and this stuff has had a chance to settle. It looks a little strange. Strange color graduation, green at the top to brown to the gold at the bottom. Now the brown may just be fine suspended carbon particles, I suspect. I saw that in my small scale test, the first one I did off camera. Now my small scale test was not nearly so green though, so I think maybe doing more chips, I didn't get as much of the metal out as I did on the small scale. Maybe a little bit more hydrogen peroxide might have helped. Anyway, we got gold on the bottom of the beaker, so I am going to do my usual thing. I'll siphon the liquid off and I'll get the gold in a smaller beaker. I'll give it some cleanup boils and dry it out, and then we'll weigh it. Well, here's the gold. It actually looks pretty good considering the color of the liquid it was precipitated from. That doesn't look too bad. It's the right color. Looks like it's gonna hang together. Alright. So I'm gonna get this into a smaller beaker and start giving it some cleanup boils. And then we'll be able to dry it out and weigh it. I mean, it looks like a fair amount in here, but I'm not expecting a huge amount because I know most of the weight of that 100 grams we did was those heat spreaders. So, but we got some gold. So let me get it cleaned up and we'll weigh it. Okay, first cleanup boil is happening. The liquid's still a little bit green from the leftover liquid that was pulled over after I was done siphoning, but I'm going to give it 2 more cleanup boils in distilled water, and that should clean it up nicely. The gold looks really good. It's all laying on the bottom of the beaker. It's not all mixed through the water column from the turbidity of it. It looks like good gold. You know, it's not colloidal or semi-colloidal. I am shocked at how good this gold looks. So after 2 more cleanup boils, we'll dry it out, then we should be able to weigh it. All right, the gold's had its cleanup boils. Just drying it out. Be able to weigh it here in a few minutes. See how much we got. Alrighty, it's the moment of truth. Well, that gold really shrunk down to almost nothing as it dried out, which I was expecting. Gold always looks like a whole lot when it's wet, but once it dries out, well, I still think there's enough here to weigh. So we can calculate a yield, although the yield really isn't all that important because it was kind of a random mix of different types of chips, and I'll probably never do that exact mix again. But it is kind of nice to know how much gold you got out of an operation. And this experimenting has shown me that I think scaling this up is practical. Or maybe, you know, I'll just go back to incinerating. You know, I don't like to incinerate most of the time. But, you know, when it comes to silver, if you're just trying to get a few grams or an ounce or two of silver, that's not a lot of money to be risking all the pollution and the potential of annoying your neighbors. But if you're going after grams of gold, that's a different story. I might find a good day to incinerate, you know, when nobody's around, and, you know, gold's a different story. Yeah, not that much. What we got here? 0.15, 0.14, make up your mind. 0.15 of a gram. Okay, 0.15. All right, so since we started with right around 100 grams, actually 103 I think it was, it makes the math pretty easy. We should be about 0.15% yield, but it's actually 0.14563, yada yada, because we actually started with 103 grams. But yeah, so about 0.15%. But this could be easily scaled up, I think. Not too much trouble there. And with a little more back of the envelope calculating, we've got not quite $20 worth of gold here. So yeah, not a great showing for all the effort that went into it. But you know what? I'll bet we didn't use $20 worth of chemicals. I don't think so. So yes, I think this has promise for scaling it up. Quite possibly, we might see in the future. We might try it on a bigger scale, or I might go back to incineration. We'll see. Anyway, I'm going to add this to Johnny's growing gold repository, and I think that's going to grow a lot faster in the future as I scale up some of these processes and tackle more of his stuff. So subscribe to see those future videos. Thanks a lot for watching this one. I hope you found it educational, interesting, inspirational, whatever. If so, give it a like, and I'll see you in the next video. Bye.